Good morning, everyone. Thank you for joining me. My name's Nikki Kruger, and this is a presentation on the dripping point. Tight homes plus energy efficient HVAC systems equals increased of risk and moisture problems. Looks like we have quite a few people still joining us. If you have any questions, go ahead and put them in the chat. Or in the questions tab, and I will try to address them as we go along. And we're going to go ahead and get started because we have a lot of content to cover here. All right. So first of all, a little bit of background. Santa Fe Dehumidifiers is a brand of thermistor. We are headquartered in Madison, Wisconsin, and Santa Fe specializes in whole house ventilating and freestanding dehumidifiers. We also manufacture Quest, which is our commercial climate control dehumidifiers, and then Phoenix restoration equipment also. And all of this is in our factory in Madison, Wisconsin. And I mentioned our commercial and our restoration equipment because a lot of the same components that are used in those dehumidifiers are also used in our residential dehumidifiers. So you really are getting a commercial grade residential unit. So a little bit about me. I've been involved in the indoor air quality industry probably close to 20 years now. Very involved with ACA. Helped develop the 2-day crawl space encapsulation class that we actually have going on in Madison next week, and AMA ResNet certified home energy rater. So some definitions and terminology as we get started. When it comes to dehumidification, we often say pint and pound interchangeably, and a pint's a pound the world around. So they mean the same thing. And then 1 CFM out equals 1 CFM in, which is extremely important when we're considering our ventilation strategies. So sensible load is the temperature that we feel that is often controlled by the thermostat, and the latent load is the moisture in the air, which is referred to as relative humidity. And this can be much more challenging to control with the thermostat than it used to be in the past. And we're going to dive into how our homes and our equipment's changing and affecting that. So thermodynamics, hot goes to cold, wet goes to dry, and high goes to low. I always start with this because it's so important to understand how the outside is affecting our inside. And as our homes get tighter, how we're trying to prevent that from happening, but everything that we need to take into consideration as we make our homes tighter. So what are we trying to provide with our HVAC systems? So comfort, health, and property protection are the three major for the homeowners. For our building partners, liability protection, and we're trying to do all of this with the lowest energy bills for the homeowner as possible. What are we trying to achieve with the HVAC system? Well, heat, cool, dehumidify, possibly humidify, purify that air. We need to ventilate in every room 24/7, 365, and again, as energy efficient as possible. Today, we're going to focus on the cool, the dehumidify, the ventilate, and then hopefully as energy efficiently as possible also. I'm just going to click on the chat here, make sure there's nothing. So our manual J bullseye for cooling for designing is 75 degrees and 50% relative humidity. So when we're designing the AC system, we're designing for peak loads for 75 degrees and 50% relative humidity. The reality is when we're designing these systems that they're going to run at 1% of the time at that peak load condition. So the challenging part is how do we control that relative humidity or that latent load when the AC is not running. So the ultimate goal, every energy efficient building standard program is to build as tight an envelope as possible to reduce the amount of runtime on the HVAC system. So, and we're going to be seeing this even more and more with our Inflation Reduction Act, with the increase in benefits for insulation, adding air sealing and insulation, and then higher efficiency HVAC equipment being used. So again, that higher seasonal energy efficiency ratio, so that higher SEER HVAC equipment, which is leading more to partial and low loads on our HVAC systems, even in hot, humid climates. And so we're also getting better sensible control with these higher efficient HVAC systems, because they're getting to that thermostat temperature more quickly. But it's at the cost of removing the latent load. The shorter the run times, the less water that we are going to remove. So advances in low load homes are really advances in low sensible load houses. So, you know, we have continuous insulation, driving down that sensible cooling load, airtight construction. That's helping with driving down the sensible cooling load and the latent cooling load by not bringing, allowing air to infiltrate from the outside when that hot goes to cold. The challenge is we're going to have to do that with mechanical ventilation, which you can see can increase our sensible load and our latent load. Now, ducts in conditioned spaces is going to drive down that cooling load. And I would also say that it's going to drive up our latent cooling load, because as soon as you put ducts in a conditioned space, the AC will run less, because we're not losing that conditioned air into an unconditioned attic, causing the air conditioner to run longer, which actually helped remove more moisture. Now we're trapping all of any potential leakage from our duct systems into the house, which is going to reduce the runtime, which is great, but also we're not going to run as long and remove that moisture. So low load homes, what the definition of a low load homes for low sensible cooling starts at about 1,600 square foot per ton. And then as you can see, our building codes is making us tighter. And then when we get to the net zero, and we talk about the Inflation Reduction Act, really is going to be driving builders and homeowners to be looking more at Energy Star rated homes and net zero homes. I think the benefit is $2,000 for Energy Star homes, and then $5,000 for net zero ready homes. So as you can see, we are pushing our homes to get tighter and tighter. So high performance building practices. We have verified tighter envelopes. We're doing blower door tests. We're stopping infiltration as much as possible. Verified ventilation CFM. We're actually installing the equipment and verifying that that ventilation equipment is bringing in the recommended of outdoor air. And that is for indoor air quality purposes. That's not for energy efficiency. I mean, you want to use the most energy efficient ventilation strategy as possible, but we're running ventilation for indoor air quality, for health, for comfort. We have lower sensible loads in our homes. We have more energy efficient HVAC equipment. We have a greater need for dehumidification in a large part of the country. We say green grass climates. So if you look outside during the spring, summer, and fall, and you see green grass, most likely you're going to need some form of dehumidification. That's going, and that could be that maybe your AC at peak loads is going to handle that, but the shoulder seasons is very challenging to handle that, that latent load. So traditional practices, houses are built very leaky because they need to breathe. The flow of the air of the home is not managed. Indoor air quality is not controlled. We have high energy bills. And if someone needed a dehumidifier, fingers started pointing. Somebody did something wrong. And that's all changing. That's all changing. The reality is we're building tight. We're bringing in the recommended of outdoor air for ventilation. We're using the high SEER HVAC equipment that's sized correctly, and you need a dehumidifier. You're actually doing everything right. I was just at the International Builders Show a couple weeks ago, and Dr. Joe Steenbrook was up there, and he said the same thing. So if you need a dehumidifier, you actually are doing everything correctly. So factors that can lead to high humidity: tight buildings. If we're trapping moisture inside, and then we're also bringing in high moisture from the outside for ventilation, we're probably going to need something to control that. Of course, leaky buildings, but we want to make sure we tighten up those buildings as much as possible. Construction drying is a huge one. You can get a couple thousand pints or pounds of moisture just from a wood-built home that is going to have to be managed for several years before it actually dries out. And you're only drying if you've got something to dry that home. So lots of wood. We have low loads, mechanical ventilation, high SEER equipment, high dew points outside, leaky ductwork, people generating moisture. And then the challenge is we design these homes and we can install the equipment correctly and we can design the most beautiful system, but as soon as you hand over that thermostat or that comfort control center to the homeowner, you've lost all control. You have no idea how they are going to operate their home. What I want the thermostat at is much different than what my husband wants the thermostat at. So there's a lot going on that's actually going to determine the amount of runtime on that AC system to control moisture. So the need for dehumidification is significant. We've got health, we've got comfort, we've got the protection of our personal belongings and the overall structure of the home. So there's a lot of organizations that have recommendations for relative humidity. Relative humidity is relative to a temperature. We got to make sure that we understand that when someone says that they've got 75% relative humidity in their home, potentially their crawl space, we need to know the temperature. The higher the temperature, usually the lower the RH, and the lower the temperature, the higher the RH. So that's when we get into really understanding, we need to understand what the dew point is, how much real moisture is in the air. But wintertime, if we can keep it at around 25, which might mean in some parts of the country you're adding, but in the spring, summer, and fall, we really don't want to go above that 50% in our homes. And that's what Manual J has us designed for, is 50%. So here's a dew point map in conjunction with our climate zone map. And as you can see, where the moist area is, that A along the top there on our climate zone map correlates where we have higher dew points in our dew point map. So this is a dew point map from late September. We've got 70-degree dew points in the Northeast all the way down to Texas and Florida. So we're probably not running a lot of air conditioning, especially in the Northeast. Probably partial load potentially down in Florida, because who knows, we're not sure what the temperature is, but I guarantee it's probably not peak load. But we've got the same amount of moisture in the air. So that's the challenges that we're facing as an industry, is controlling the moisture when our AC is not running. So sensible loads vary throughout the day. So if you look at this chart here, we've got 8 a.m. in the morning, we're at about 74 degrees. We go to 4 o'clock in the afternoon and we are at around 93 degrees. So the sensible loads will vary drastically throughout the day. Now, if you see here on these charts with the humidity outdoor, as I said, when the temperature is lower, the humidity is higher. When the temperature is higher, the humidity is lower. But in reality, the latent loads are exactly the same. We have a 71-degree dew point, whether it's 8 o'clock in the morning or 4 o'clock in the afternoon. We have the same amount of moisture in the air. So in that 71-degree dew point, that could be Louisiana, June, July, and August. overnight time as well. So we've got, and then also the shoulder seasons, potentially through the Northeast all the way down. So we've got to figure out, that's our ventilation air that we are going to need to bring in, especially in our tight homes. How are we going to handle that moisture? We've got some great data here from Mike Barksek. He had put this together and has given me permission to use it. But this is Atlanta, Georgia. And you'll see here that the design, the Manual J design temp is 92 degrees. The ASHRAE humidity design is 82 degrees. So that's when we're going to have the highest dew points in Atlanta is 82 degrees. And then if we look at our bin temperatures up here, you can see that 94% of the time, even a little bit more, we are nowhere close to our peak load conditions to run that AC. We're at partial load conditions or no load. So that's a real challenge, especially with that having to bring in that outdoor air, that ventilation air, on how we're going to manage it. A friend of mine, Kimberly Llewellyn, who works for Mitsubishi, put together this great chart on partial load conditions where you're between about 50 and 80 degrees at higher than a 55-degree dew point, and the hours of the year that all these locations are above that. So as you can see, Miami, 4,375 hours of the year, you are at partial load conditions, all the way down to, I mean, even Phoenix. We do sell dehumidifiers, believe it or not, in Phoenix because of monsoon season. So, which I always find interesting. So the air conditioner, designed to get to that set point. Yes, we've got dehumidification mode now, but most of the time it is still overcooling to dehumidify, and there has to be a load for it to be cooling. And you typically need about 14 minutes of runtime to get effective dehumidification, meaning that the coils have loaded and that water has started to drip down and out of the house. So our SEER ratings keep getting higher and higher. We are getting really energy efficient HVAC equipment. They're using larger coils that are very efficient at cooling the air, resulting in less runtime. These larger coils hold about a pint or a pound of water per ton. So you have a 3-ton system, you got 3 pints of water on the coils. The coils don't get as cold as they used to. And one way that they kind of cheat the system a little to increase the SEER rating is they will run the fan for 1 to 3 minutes after the compressor shuts off. So you get they're getting points for evaporative cooling, which again, if you're in Arizona, evaporative cooling probably isn't a problem. But if you're more in a humid, mixed humid climate, that AC runtime that you just used to remove water will be mitigated, because now you're going to increase the RH up to 10% by running that fan after the compressor shuts off, because it's all going to re-evaporate back into the house. So sensible heat factor is something that we are discussing more and more when it comes to designing the HVAC systems. We really need to understand how much water that piece of equipment is going to remove when it is running. We need to know our sensible heat factors. So here's a chart here of some equipment. We've got a 14 and a half SEER piece of equipment with a 62% sensible heat factor. So meaning when it's running, 62% of the BTUs are focusing on cooling, and the other 38% is focusing on latent removal. So when this piece of equipment's running, it's doing a pretty good job of removing moisture. Whoops. Now we've got a 33 SEER piece of equipment, a half-ton ductless mini split, and 96% of the BTUs are focused on cooling and 4% on latent. So when we're using these ductless mini split strategies, we're really going to have to think about how we're going to handle the water removal, because they're so energy efficient at cooling a smaller space. So variable capacity equipment, we get this all the time. Well, I'm using variable capacity, I'm getting the dehumidification that I need. They typically have a higher than average supply air temps. So, you know, again, those coils aren't getting as cold. Their sensible heat factors are higher, meaning they're not removing as much moisture. And still, 2/3 of the BTUs are focused on the sensible, and 1/3 is focused on the latent, and you still got to have a load. You've got to have a load for the AC to be running. So homes need dedicated dehumidification for comfort, health, property protection, those partial to no load times. We can't control humans, and really it is the only way to ensure 50% RH, because you cannot control how they're going to run that thermostat. So a whole house ventilating dehumidifier, many of you probably knew us as Ultra Air before the units were rebranded underneath our Santa Fe, which was our standalone crawl space and basement dehumidifiers, both residential. We just combined them underneath one. We invented whole house ventilating dehumidifiers back in the mid 90s. Ken Gehring, a gentleman who's still working with us, he's 84 years old, invented these. And it's designed to bring in outdoor ventilation air. So we're a supply ventilation strategy to try to put that slight positive pressure, especially for mixed humid and humid climates. That's important. We filter with the MERV 13 filter, and we dehumidify all the air in the home independent of the AC system. And this is what an install would typically look like when utilizing that outdoor ventilation air. You don't have to. If they're using another ventilation strategy and they don't want to use the dehumidifier for the ventilation, there's a damper in there and you just cap that right off and you don't have to. So it's the best option to reduce customer callbacks and really to reduce builder warranty claims. We've had some builders that we've worked with that have had a lot of issues with humidity and have recognized that after they install the dehumidifier that their warranty claims and callbacks go way down. So mold won't form, odor from bacteria is minimized, comfort levels go way up, especially overnight periods. A lot of times when people get up at night and they start cranking down that thermostat, it's not because it's the temperature, it's because it's just too humid in the air. And we're seeing an increase in this, especially with our partial to no load run times because of how tight our homes are getting. Indoor air quality can be achieved when humidity levels are high. All the products that you bring into your home will off gas quicker and at higher levels when humidity is high. So if you ever heard of Chinese drywall, down in Florida, it off-gassed at high rates. It called pharmacary corrosion on the HVAC systems, refrigerators. They know that drywall made it farther north, but they can't find it because the humidity levels weren't as high for extended periods of time in order to cause the problems. So again, a lot of VOCs can be minimized when the relative humidity is controlled. We protect our hardwood floors, our cabinetry, when we control the relative humidity, and also pests. So install matters. This is so important. We get calls, we get homeowners that are upset, we get HVAC contractors that are frustrated because they installed a dehumidifier, but it wasn't installed correctly. So we want to make sure as much as possible that we pull from a dedicated return to the dehumidifier and tie in to the supply of the HVAC system. This allows us to not have to run, we can lock out the AC and the dehumidifier from running at the same time. So maybe our strategy is we allow the AC to come on, run till it hits that temperature set point. When the air handler shuts off, and the RH is still too high, the dehumidifier comes on and dehumidifies. This also minimizes a lot of static issues with the HVAC and the dehumidifier together. If you are in Florida, this is one way per code that you can install a dehumidifier. The other way is supply to supply. You cannot pull from the HVAC return and tie into the supply of the HVAC system for the dehumidifier, and you cannot go return to return any longer in Florida. So, and the reason for that is this is what the return to return would look like. Florida Solar Energy released a study in June of 2018 that basically said a return-to-return install is the most ineffective and inefficient way to install a dehumidifier. I've had contractors call me saying, I installed your dehumidifier, and over a week's period of time, the RH actually went up in the house. And the reason being for that is they installed it return to return. That's the first question I asked. How'd you install it? Return to return, because it was the easiest way. I couldn't get to the supply. But it heats up the coils of the AC system, which means that we get less latent removal from our air conditioner. And we're counting on that air conditioner when it's running to remove moisture. And then when that AC system shuts off and the dehumidifier comes on, it blows all that water back into the house. And that's what typically is happening when I get those calls. So go in, put it on the supply side, tie in the supply side, and everything works. So we do not want to tie in on that return side. Now you'll see it in our manuals. We understand sometimes that's the only way, but that is our least recommended of all of our installs. And we do share all those cautions that you need to understand if you're going to do it that way. So size matters. That's a question that we get quite often. Actually, I was just working our technical phone lines yesterday, and I'm going to share an actual email that I was working with yesterday with a homeowner. But we need to understand how much dehumidification we're going to need in our homes. And you can't just go by always someone saying, you know, this is what I think I need and not understand a lot more. And here's what I'll go into that a little bit more. So this gentleman said, I have a question about sizing. There is a dispute between the environmental engineer and an installer about the size of the Santa Fe unit. He had a 1,900 square foot house. So the engineer basically is telling him that our Ultra 98 is undersized for the job by the contractor because he wanted to use continuous ventilation of humid, fresh air. And he just told him that the engineer just told him that the Ultra 98 would not be capable of that. Now, we typically say up to 2,300 square feet for our Ultra 98, which is very conservative. And so ultimately, I think it should be able to handle this, but he's asking our thoughts. And so I have to go back to him and, you know, ask. I have a lot of questions to understand more on, you know, why this engineer is telling him that it's not enough. So I don't know how much CFM that he's trying to bring in for continuous, I'm assuming continuous ventilation. I do go into, you know, asking what number are they trying to get? Are they trying to meet 62.2? And if they are, what year? We need to know that. Are they planning on running continuous or intermittent? Is there a manual J done on the home? That helps us a lot to understand what the latent loads that they're trying to deal with that home. Do they know how leaky their house is? Was a blower door test done? Where's the ductwork located? And did the engineer provide the sensible heat factor for their HVAC equipment? You know, we need to know when the AC is running, how much we can count on that AC system to remove moisture, because we are a supplemental dehumidification system. So went on to explain that there's a lot that can go into dehumidification. The reality is, most of the time, we are so conservative in our recommendation per square footage that it should cover it. 99% of the time, it covers because we are so conservative. We would rather have the dehumidifier oversized than undersized. So, and his response back was basically, it was really hard to have a conversation between the HVAC installer and the engineer. And a lot of them just don't understand these dehumidification systems, which we are seeing. I mean, we've seen a huge adoption of our equipment over the last 10 years. There's no doubt, but there's still a lot of installers that believe the AC can handle it 24/7, 7 days a week, 365 days of the year, depending on where you live and what your latent loads are, that AC system is going to be able to handle it. So it was a very eye-opening conversation, again, because I feel like we've made such large leaps in getting dehumidification adopted, but there's still a long ways to go. And we are going to be in a tough situation the tighter our houses get, and the pushback that we get from the industry on actually utilizing dedicated dehumidification systems. So how do you size a dehumidifier? We got manufacturer's recommendations. You got to be very careful with that. There is no governing body that actually determines what I can claim per square footage for my dehumidifiers versus what my competitor. I might say I do say 1,800 square feet for our 70 pint. My competitor can say we can do 3,000 square feet with our 70 pint. You got to be very careful with that. There's nobody that's determining what the claims can be. And again, we are very conservative in our numbers. You have AHAM, Manual J, and Manual S, and we'll just kind of look at those quickly. So Manual J actually gives you a calculation based on your Manual J loads. So what it might look like here is my latent load is 7,170. It takes 1,054 BTUs to remove a pint or a pound of water. So we divide that, and then we're going to multiply that by 24 hours in a day, and that's going to give me about how much dehumidification I'm going to need. And then I got to figure out how much of the time can my AC handle that, and how much of the time am I going to count on a dehumidifier to handle that. Manual S, it's very similar. The challenge with Manual S is it's going by, Manual J is 50%, Manual S is 55%. That is going to be changing. We're actually working with ACA on an updated version of Manual S that is going to be actually discussing dedicated dehumidification a lot more than it does now. It's going to be one of the prime factors in picking out your equipment, is if you are using a dedicated dehumidifier moving forward. So big changes with Manual S coming down the pike. We do have a resource. It's still branded Ultra Air because the amount of money to update this app is astronomical. But what this allows you to do is the inlet is the temperatures that are outside, the conditions outside. So it's 88 degrees, 75-degree dew point outside. Inside, I want 74 degrees, which is the outlet. So the outlet is inside, 74 degrees, 52% RH, and a 55-degree dew point. The flow is what my ventilation number is. So based on these inputs, you're going to need 106 pints a day of dehumidification just based on your ventilation. And then you need to figure in your occupant load as well into this. And the little eye up there in the corner, you can change it from pints per day to pounds per hour as well. So this is just kind of a guidance based on ventilation. It's always great to use just to figure out what the dew points are going on also. And then we do, in the handout section of the webinar here, I did upload this piece of literature. It is also on our website, but we break down our latent capacities per hour for each one of our dehumidifiers at the different conditions. So we have AHAM, which is 80 degrees, 60% relative humidity, and then the new DOE, which is 73 degrees, 60%. Manual S is 75 and 55, manual J is 75 and 50. And just because we know a lot of homeowners like their master bedrooms much cooler, we did put in the 70 degrees and 50% relative humidity as well. And it shows you, obviously, as the temperature is lower, a 70-pint dehumidifier is only 70 pints at 80 degrees, 60% relative humidity. As the temperature is lower, and the RH lowers, then the capacities become less. And that's all dehumidifiers. And we are sharing this performance data because we feel that it's very important to the industry to understand this when applying a dehumidifier, to make sure you're getting as much dehumidification as you need. So I'm going to jump into crawl spaces here because we need to understand that encapsulated crawl spaces are becoming more and more of our tight homes, and they're actually trying to utilize the air conditioner to condition these spaces. I was just at a spray foam conference this last week and talking to a lot of spray foam contractors that are doing crawl spaces, and it was alarming and eye-opening to me on what some of these contractors are doing. But so 250,000 new homes built every year on crawl spaces. There is an estimated 76 million homes that already have crawl spaces. And due to these energy efficiency building codes, we are seeing a massive increase in crawl spaces being encapsulated. And this is driving for that if the HVAC system is going to be located in the crawl space, that they're driving, these building codes are driving it to be encapsulated. So for instance, if you're in Washington State now, they are incentivizing builders to put the HVAC equipment in conditioned spaces, meaning that the attic's encapsulated or the crawl space is encapsulated. And I think that we're going to see that more and more, just because we know the amount of air leakage from our systems that is very energy efficient and inefficient. So we're going to be seeing our attics and our crawl spaces conditioned much more as part of our building standard programs. So you encapsulate it because of air leakage. You can reduce the RH in these spaces when they're encapsulated. A lot less rot. We can protect the homes a lot better. Termites and other pests cannot thrive in these conditions. And high humidity from the crawl space contributes to microbial growth, structural issues, and poor indoor air quality, because 50% of the air below the home, it's making its way into the living space. Now, the current energy code for 2021 requires that you condition that crawl space. So you can use continuous exhaust, but you've got to be able to have a transfer grill for an air pathway to make up. You can use conditioned air supply, plenum in existing structures. That's not something that we're going to discuss. And then dehumidification sized in accordance with the manufacturer's specifications. So that made it, dehumidifiers made it into code in 2018. Unless you are in North Carolina, dehumidifiers have been in code forever for crawl spaces. But it's been updated for 2021. So it's in accordance with the manufacturer's specifications. Again, that's saying I can claim one number and the competitor can claim another number. So really understand how those dehumidifiers are going to work in a cooler space like a crawl space. But the number one way that I see crawl spaces being conditioned, because it's inexpensive, is utilizing the conditioned air supply in the crawl space. So they are basically just putting in a properly, hopefully sized supply register onto an existing air duct, supply duct, and they're pushing some of that supply air when the AC runs into the crawl space. So it's drier air because it has hopefully been dehumidified by that air conditioner, but it's also cooler air. So if you've got 59-degree air going into a cool space like a crawl space, you can potentially get condensation and create worse conditions down there by utilizing that air supply. The pros, very little equipment needed. The cons is it's only diluting moisture, and it's only running based on the comfort of the occupants in the living space. And typically it's not going to be running in the spring and the fall very much because we don't have an AC load at those times. So again, it's really not a good strategy for controlling the moisture that is in the crawl space. Now, one of the spray foam contractors I talked to last week, asked him what it, he's like, oh yeah, we're encapsulating crawl spaces in Michigan. I'm like, oh, so what's your control strategy? Oh, I just go in with a screwdriver and I pop 2 holes in the supply ductwork on each end of the house, and that'll condition the crawl space. That's alarming and very concerning to me, but it's also not very uncommon. So there is a huge benefit into educating HVAC contractors to our builders that as we start encapsulating these crawl spaces, that really the only thing we need is a dedicated dehumidification strategy. We just need to dehumidify it. If we've air sealed it and insulated it correctly, there should not be that big of a difference in temperature. We're really just concerned about that moisture. So this is what that would typically look like. They're just popping in that supply register into the crawl space. We actually did a study on 2 habitat houses in Northern Virginia where they were both on the same, right next to each other in the same lot, built to the same energy standard, the exact same footprints of the homes, the blueprints. One of them we used a dehumidifier and the other one we just used the AC supply. And what you can see here is the dotted line that's orange is the RH. Now, they had to do some mold remediation before they actually closed up these crawl spaces. And so we were trying to really keep that crawl space dry down there. So it was set a little bit too low at first. But you can see we kept it at a 40%, even though the solid orange line, which is the RH outside, was up to 100%. We had rain going on some days. But on the right side, the AC supply was utilized in the other crawl space, and that dotted orange line was consistently above 60, almost, I was getting alerts because we were monitoring that it was consistently hitting 70% during that time frame. So it does not control the RH in those spaces. And again, we're talking April, not a lot of AC being run in Northern Virginia at those times. So one of those things that we really will be beating our drums at more and more with encapsulation. And I do see as our houses continue to get tighter that some of these strategies that are being used in our crawl spaces right now per code to condition probably will not be allowed because we're really not controlling the moisture down there with those strategies. So a lot of times we get questions on, well, if I'm building a very energy efficient, tight home, and now I have to add another piece of equipment, and don't dehumidifiers use a lot of energy? And the reality is they're very effective and energy efficient at controlling the moisture. And if you can set that thermostat higher, because you are more comfortable when you control the relative humidity, 85, 90 degrees in Florida is very different than 85, 90 degrees in Arizona. It's oftentimes it's not the heat, it's humidity, right? So, and Florida Solar Energy says each degree lower you set that thermostat, which is what people do when they're uncomfortable, the AC use goes up by 12%. So that's quite a bit of energy. But this is a residential energy dynamics. They have this free calculator on their website. I used its ventilation electrical usage. I just took the watts of our 98 pint dehumidifier, which is 670 watts. And I said for 270 days of the year, this dehumidifier is going to turn on for 20 minutes of every hour. So obviously I'm in a hot, humid location, if that's what's going on, or at least a humid location. And my cost per kilowatt is 11 cents. So my annual electrical usage for our 90-pint dehumidifier is going to be $159. So again, very energy efficient at controlling the moisture in the air. And in the words, for those that you know, Dr. Joe Steenbrook, who started Building Science Corporation, you cannot energy conserve your way to dry. Just like ventilation, moisture control, comfort with our ACs, it's all going to cost you some money. It's just a matter of installing them the most energy efficient way possible, and then really maximizing the dehumidifier, knowing that the AC isn't always going to be able to handle it. So key takeaways: houses are becoming tired and requiring less sensible conditioning, yet our latent loads aren't changing and possibly going up. There must be a sensible load in order to remove humidity. AC is only going to remove moisture when it's running, and it's got to run for a period of time in order to do so. Houses work until you put people in them. You can't control how they're going to run that HVAC system. And people want homes that are safe, healthy, durable, and comfortable all the time. So a couple takeaways for you, those of you that utilize or are using Santa Fe, and those that are not. We are far more than just single family. We have an in-wall dehumidifier. We're actually heavily involved in multifamily housing, everything from affordable up to luxury. And then we also, our units get applied in commercial applications all the time, like commercial self-storage, military, pet grooming. So if you have any of those projects that you have questions on, please reach out. We are happy to work with you and consult on those. I did mention we have a 2-day encapsulation course next week in Madison. We hold these at our factory. So it includes a factory tour. It's building science. We teamed up with Joe Steenbrook from Building Science Corp, Advanced Energy out of North Carolina. It's all the building science of encapsulating crawl spaces. Our class next week is full. There is no charge for the class, and I think we're looking at offering another one in May for those that want to learn more about it. But we've done it for about 6 years now, and probably have had 12 to 1,500 contractors go through this course. And then we have a lot of resources. One thing that I want to make you aware of, our contractor portal. Please make sure that you sign up for that. You can be put into our dealer locator for homeowners to find you. And we also, in the next month, you're going to see a lot more service videos that are going to be put into the contractor portal about troubleshooting dehumidifiers and expanded install video instructions. And then all of our webinars will be placed in there as well for you to go back and look at those. We did make a change recently. It was only allowing for one website address to be utilized. So if you had several people at your location and they all used the same website, your website, it wouldn't allow you to register. We've now removed that. So multiple people from one location, one business can utilize the same website. We do have a Santa Fe service app that has all of our manuals and spec sheets and product videos that you can download onto your phone. Just Santa Fe Indoor Air Quality Solutions on your app store. And if you're looking for other resources, manuals, that sort of thing on our website, it's underneath the About section, and you'll see media resources. And that's where you would find logos, pictures of our units, manuals, discontinued manuals, that sort of thing. And then, as I mentioned, the where to buy. If you are using Santa Fe products and you want a homeowner to be able to find you, then you can go ahead and sign up on our contractor portal, and you can check yes that you wanted to be listed on the where to buy, and we can direct homeowners to you to call if they are interested. And that is all I have today. Thank you all very much for joining. I don't think, oh boy, I guess I did, I missed some of the questions here, so I'm going to Does wet also go to cold? Wet goes to dry, not necessarily cold. So it'd be going more by the dew point versus the RH when we're looking at wet going to dry. The PowerPoint is going to be available after this webinar. I will go ahead and it'll send an email to all of you letting you know that you have access to this video. Should dehumidifier equipment be standalone system or should it be integrated with the HVAC system? Which is better? I would say that if we're talking standalone, meaning the dehumidifier has its own ductwork separate from the HVAC, that is always going to be ideal. But it's also, that's like giving an ERV its own ductwork, which is recommended by the manufacturers. We don't necessarily recommend it like ERVs do. We're only using that supply, hopefully. And the reality is, if you look at a lot of the data, HVAC equipment and dehumidifiers typically don't run a lot at the same time. They will, but most of the time when the AC is running and it's sized appropriately, it should be for extended periods running for extended, it should be handling that moisture load. So us utilizing that supply ductwork shouldn't be a problem, but we do have contractors more and more. I know Matt Reisinger has been doing this more in some of his houses. If you know Matt Reisinger on the Build Show, he uses our dehumidifiers and he is starting to give them their own ductwork now. So he can control more where that dehumidified warm air, ventilation air is going. You just got to make sure that you are giving it more than one supply register. We don't want all that warm dehumidified area going into one place. We need it spread out more throughout the house so we don't create a comfort issue. If you're using ductless mini splits and you are giving the dehumidifier its own ductwork, which we're seeing more and more, we want to make sure that we're putting the supply, typically 3, we recommend 3 supply trunks, and we're putting those as close to the ductless mini split heads as possible. And that's so we, again, don't create where we're warming up one specific room. So otherwise, a standalone by itself, we see this with our in-wall ND33, again, used in ductless mini split houses. We want to try to centrally locate that as much as possible. A lot of multifamily. We're going to have to leave bedroom doors open. We're going to be able to make sure that when we use a standalone application, that we do have communication going on through the different parts of the house. It can be done. I would make sure that if you're utilizing an in-wall dehumidifier in a, like a living room central location, and the master bedroom is at the other end of the house, because master bedrooms with en-suites are notorious for having moisture issues, that's probably not going to be the best strategy. I also don't want to put an in-wall dehumidifier in a master bedroom, again, because we're generating some heat. And while they're, the in-wall dehumidifier only has a dBA and decibel of, like 46, it will be the only thing they hear at night when it comes on, because it's going to run at night more than any other time. So that would be a ducted application for sure when it comes to trying to control moisture in master bedrooms with suites. In using RH or dew point recommended for biological growth control, and why? So dew point is where we're going to get like physical water condensation. High RH can lead to moisture loading, and we go over this in our crawl space encapsulation class, because that is adsorption. So what happens is Dr. Joe Steenbrook wrote a paper on it where the molecules of water will start layering. So you're not actually on like your drywall, you're not actually seeing water, but you're seeing what is moisture loading on materials. They're becoming more and more saturated. So you might feel it and it might not actually be wet, but we're getting moisture loading in those materials. So both of them will lead to biological growth. It's just when you hit dew point and you got condensation, it's probably going to happen much quicker. But what we see happening as our homes are getting tighter and tighter is in the springtime, we'll start moisture loading with ventilation air, not running a lot of AC, and then potentially not running a lot of AC over the summertime to actually dry our materials. That come August and September is when we see evidence of biological growth. So that's when we get a lot of phone calls with people trying to figure out why they have biological growth, but it's moisture loading that is happening. So both of them will do this. This presentation will not be loaded on YouTube, but it will send you that you'll have access to it, and that we will be putting these in our contractor portal in the next month or so. And I think that is all the questions that we had. If you have any others that you think of, please feel free to reach out to me with an email, and I will be happy to answer those for you. Thank you, everyone, for attending today, and have a great day. Thanks.